All right, so the second question is going to be this. What is the maximum mass of ethyl ethanoate that can be obtained from 0.1 moles of ethanol? How are we going to do this? Well, the first thing that we want to do is realize that this is a stoichiometry question, right? We can see this is a stoichiometry question because they gave us an amount of one thing, so the amount of ethanol over here, and they ask us for the amount of something else. So I know here they aren't technically asking us for the amount. In actual fact, they're asking us for the mass, but we realize that we need to find the amount of ethyl ethanoate before we can find out what the mass of ethyl ethanoate is. All right, so I've gone ahead and written the balanced equation for the reaction here. If you don't completely understand what ethanol, ethanoic acid, ethyl ethanoate are, don't stress, we'll go over this in organic chemistry. But right now what we can see is this. They asked us the maximum mass of ethyl ethanoate from 0.1 mole of ethanol. So I always like to draw an arrow saying what my inputs are. So in this situation, I have 0.1 mole of ethanol, and then they're asking us for the mass of ethyl ethanoate. So ethyl ethanoate, I'm going to draw an arrow going away from it, and they're asking us for the mass. And what is that going to be? Okay, so first of all, I realized that we need to find out what the ratio is between ethanol here and ethyl ethanoate over here. And I can see very simply that there's a 1-to-1 ratio. So it's very simple for us. So let's have a look at the thinking now. I have 0.1 mole of ethanol. How many moles of ethyl ethanoate will 0.1 moles create? So I've realized 1 mole of ethanol creates 1 mole of ethyl ethanoate. So 0.1 moles of ethanol will create 0.1 mole of ethyl ethanoate. So that's done and sorted. The problem here though is that so I realize here that this is going to give us 0.1. Oh, whoops. Let me rewrite that. So number of moles of ethyl ethanoate, and you can realize that the N means number of moles, and the name of whatever you're talking about is in the bracket, is going to equal 0.1 moles. Okay, but they've asked us for the mass of ethyl ethanoate. So how do we deal with that? We would remember that before we talked about something known as the relative molecular mass, right? And we basically got all the relative atomic mass of everything that comprised a particular molecule, added them all up together, and that would give us the relative molecular mass. And this was like the mass of your molecule as compared to a carbon-12 or a hydrogen standard. If you took hydrogen equaling an arbitrary 1 and carbon equaling an arbitrary 12. Okay, so the relative molecular mass in this situation would equal what? The relative atomic mass of carbon, which is 12, plus that of hydrogen times 3, because there's 3 hydrogens, so that's going to be 3 times 1, plus 12 for this extra carbon here. Oxygen is 16, so it's going to be plus 16 plus 16. There's 2 carbons, so that's going to be plus 12, and we'll make that times 2, and then plus another 5 hydrogens, which is going to equal 1. So if that all adds up together, that should equal 88 grams, or 88. Okay, so the relative molecular mass of this thing is going to be 88. Remember when we say relative molecular mass or relative atomic mass, there is going to be no units. And the reason is because when we talk about relative atomic and molecular masses, we're talking about a ratio of weight. So it's the ratio of weight of this molecule compared to that of hydrogen, or compared to that of carbon. However, what we also need to realize is that the relative molecular mass is going to have the same number as what's known as the molar mass. Okay? And this is saying what? This is saying that when I have 1 mole of something, it's going to be equal to the relative molecular mass in grams. So what I'm saying here is that when we go to the data book and add up all the numbers to get this number here, 88, to get the relative molecular mass here, what this is saying is that we're saying this is equal to the molar mass, and the molar mass is basically how many grams does 1 mole of the substance weigh. So if I have 1 mole of this substance, it's going to equal 88 grams in this situation. So it's going to have a molar mass of 88 grams per mole. Okay, and this means what? This means that we can now use this, like the mass of 1 mole of this substance and the amount in mole to calculate how much the mass. And that's really useful now, because if I know that 1 mole of this substance, remembering a mole is 6.02 times 10 to the power of 23, and think of it as a bit of like a dozen. It's just a classifier or a bunch of, it's just a number, right? So 1 mole equals 88 grams, and this is for ethyl ethanoate. Then I ask myself, 0.1 mole equals how many grams? So I'll make that an X here, grams, right? So we just look at it, we realize that 0.1 is 1/10 of 1. So therefore, it should be the mass of 0.1 moles of ethyl ethanoate should be 1/10 of the mass of 1 mole of ethyl ethanoate. So in other words, it should be 8.8 grams. And that would be our final answer. So I know that this looks a little bit messy here, but how would we work this out how would you work this out on a piece of... Okay, so clear the screen a little bit. It would go something like this, right? So the number of moles of ethanol, C2H5OH, equals 0.1 moles, right? So the number of moles of ethanol, C2H5OH, to the number of moles of ethyl ethanoate, CH3COOC2H5, is going to be 1:1. So it's 1 mole of this equals 1 mole of this. Therefore, the number of moles of CH3COOC2H5 is going to equal 0.1 mole. Then I realized that the mass of this of ethyl ethanoate, C2H5, is going to equal what? It's going to equal the number of moles divided by, the number of moles times the mass of 1 mole, which is going to be big M like this, right? And if we recall back to year 11, there's this equation, N equals small m on big M, where small m was the mass that you had, and this one was the molar mass, right? So if we just rearrange this equation by multiplying both sides by big M and multiplying both sides by big M like that, we see that these two here cancel out, and we get mass equals number of moles times molar mass. So here we've got mass equals number of moles times molar mass. Okay, so we get this here, and that's going to be equal to what? It's going to be equal to 0.1 moles times 88 grams per mole. Okay, and that's going to equal 8.8 grams.